Welcome, Tom. It's good to see you again. And today, what I'd like to talk to you about is an idea that you had back in the early 1960s. It was the Trifold, basically a surfboard that folded in three pieces. It was a Morey Pope tripod. Can you tell us a little bit more about that?
I sure can. I spent a lot of time in Malibu, which was the main stage in surfing for new ideas and applied with combined with technology, and it was actually the liquid stage really, and new maneuvers were tried out there because there was always a crowd. There were starlets that came there, movie directors. Malibu, right there in the LA area. Now there was several reoccurring topics. One was a surfboard that would bounce off rocks, a rubber surfboard. Where is that? Number two, where's a folding surfboard so you can fold it up and put it in your trunk of your car, or better? And the third one was a surfboard that you could take up into the snow. Here's the snow-capped mountains in the winter when the surf is good, and we're at Malibu and watching looking at the mountains. And sometimes you're coming down from skiing and going surfing, you know. So these conversations phased in and out of all conversations at the beach while you're just lying there or hanging around a fire at an old rubber tire in a trash can. Now, Carl aspired to do something on his own. He came up with the idea of making a board that latched together with suitcase latches and how they could close down and oversized clamps and all that stuff. And he, another guy, now passed on, Tom Morey, another electrical engineer. The two guys were working in electrical engineering in Orange County. They kicked this around and decided to make something, so they made this first one with these suitcase latches in there, and they came to me. I'm Carl's pal, and I'm in the surfboard business, and he's got a little money. I could use some money, and so he wants me to fabricate something, which I did. We didn't have a decent name for it, by the way, and we hired a guy that came up with a terrific name, Trisect, and a logo with like a Y, one piece coming out. You can see the Trisect logo. John Hammersfield, McHammer, I don't know, Hammersfield, a famous LA artist at the time, came up with that.
So the Morey Pope Trisect board was born, and it was basically three pieces that were held together by latches.
Correct.
Okay.
Latched together. And I had knowledge of surfboard building and certain engineering knowledge, and so I figured out how to get the three pieces to be on figured a stand so that all three pieces, regardless of what they might be, you could vernally adjust that and then hold them, and then after you cut the bolt, you put all these things in the board, and then you saw the board at the specific areas.
Okay.
And then how to put them back together and get them aligned. That was quite a bit.
That was the tricky part.
Yeah, and we got that down pretty good.
Well, that's a tricky part today on any of these trifold boards. So we're going to use your technology to show you kind of a new way that I decided to come up with this foldable stand-up paddleboard.
All right.
So the stand-up paddleboards are about approximately 10 feet. So we're going to break this thing into three sections, each about 3 feet, a little bit more than 3 feet long. And we're going to connect these things not with latches, but with some unique methods. So we're going to use three different methods to hold these boards together.
And by the way, you got to have, it's not a trilax, you got two joints.
Two joints.
You join the first piece to the second piece, and you join that to the third piece. So there's two
joints,
yeah.
Breaking into three pieces.
Yeah, so it's a dual.
Okay.
Okay, go ahead.
Okay, that's right. It's a dual fold, but three pieces, so it's tri-pieces. Okay, that's good. So the three methods that we decided to use, since we were interested in the torque of this, is one, we were going to use pipes together. Well, that's done before. Most of them use the center pipe, but it still pivots around that with latches. So what we decided to do is to run 2 concentric pipes along the port and starboard sides.
You use two
so they align.
nicely spaced.
That's exactly it. So the second thing we do is we use high-powered neodymium magnets to actually lock that in place.
Sure.
So the tubes guide it. The neodymium magnets, these epoxy special coated magnets,
Right.
also help keep it together.
Right.
But even that, the waves will move back and forth, and there's a chance there's going to come apart, obviously.
That's right.
So what we do is we run a very high tensile strength parachute cord all through the tubing and the board, and come back to a way to cinch it down. And then this way, we provide tension onto the pipes and basically allow the magnets to hold.
Sounds good.
So the idea of the magnets, I think I showed Tom this before, is basically we have a little demo here. We have 2 of the magnets. So if we move these things like this, obviously there's no power connected with it. But if we put the magnets together like this, all of a sudden they lock in place, and they're very hard to move sideways. So we prevent any lateral shifting back and forth. Now the second thing is these things are pretty hard to pull apart. The ones that we're using here have about 9 to 10 pounds of pull. So that means you have to pull apart about 10 pounds to get them out. The latest ones we're using are about 15. So we've increased it by
Sure.
five more pounds.
Sure.
So this is basically what we have. Now, let me give you this short demo how this thing actually fits together.
Sure.
So what I do, Tom, is I have a nose section. So again, we're just looking at the skeleton here. So we'd have a styrofoam, fiberglass, carbon fiber shell over this thing. And like you say, it would be broken right in here. This would be the midsection, and of course we'd have a stern section, which I don't have on here. So the first thing we can look at then, which is obvious, is the parachute cord connected with it. So the cord starts right here, goes all through the tube, which is PEX. It's like a nylon, so it's very slippery, won't crack, won't break. And we have this cinch thing that as we pull this thing down there, it locks in place.
Yeah.
I'm
Okay.
sorry, viewers, I have very little sight, so bear with me.
I can't
Figure this out.
Okay, so Tom, if we press this button right here, see it releases. This green button, you press it,
Okay.
it's released. So these things are loose right now. So pull that cable, really tight.
It's cinching, huh?
Yeah, that's right, it's cinching. So you can cinch that down real hard, and it locks in place. So you press the button and it releases it.
Yeah.
So that holds these things, but it holds it with uniform tension all the way around. And you want to break the thing apart, you just hit the button, and lo and behold, it's free, and you can pull them apart.
You got something nice going there.
So the next thing we want to do is to show you how these things hold together. So these have magnets into them, and this is really hard to pull apart. These are 15 pounds. So there it is. I'll struggle with these. Okay, so I've got these things apart. Let me loosen my cable a little bit. A little bit more. Okay, Tom, so you can see how this thing would actually fold.
Sure.
Okay, now you notice that we have an extension on the tubes here. This tube happens to be 5 inches. This extends out 4 inches. We have magnets there and magnets here, mating magnets on the other side. So what we do is when we push this thing together, notice that the tubes align this thing perfectly. So the tubes are the first step in actually getting this cinched motion into it. Then when we bring it in here closely, all of a sudden it locks in place.
Good.
So now we've got an alignment, we've got a security, and now we take this, we have a lock. And this thing isn't going to go into place.
Neat. Great.
So this is like a tri-hold it together rather than the tri-fold, correct?
That's cute wording. Yeah.
Okay, now what we're going to do then is we'll do another segment, and the next segment we're going to actually show you the board.